Welcome to the universe of gravity and creation, a trilogy by L.S. Larkey, available on Amazon today. Distinguished citizens of our ever-advancing planet, innovators, dreamers, and everyone from stargazers to everyday families, tonight I bring to you an astonishing message, one that promises to change how we see ourselves and our place in the cosmos. For centuries, our understanding of gravity, that gentle yet powerful force guiding apples to the ground and planets in their orbits, has been shaped by the genius of Newton and the elegance of Einstein. But as telescopes peered farther and data grew sharper, we realized that standard models were leaving behind puzzling anomalies. Galaxies spinning in defiance of known gravity, the universe's expansion accelerating as though prodded by an invisible hand, black holes that defy meltdown logic, and deep cosmic singularities that our mathematics could not tame. We explained these with patchwork dark matter, dark energy, and acceptance of meltdown singularities. Yet direct evidence for them remained elusive or incomplete. Today, however, a new discovery stands at the threshold of public knowledge: the grand Febernachy unified theory of gravity. It proposes that what we call gravity might be, in fact, an exquisite and far-reaching push-based phenomenon, powered by subtle fields and fractal expansions in the vacuum of space, rather than by a mysterious mass-based pull or ephemeral invisible substances. If proven correct, this radical idea could liberate us from decades of guesswork about dark matter, dark energy, or meltdown singularities, ushering in an era of clarity and unity, one in which cosmic mysteries become luminous and comprehensible. Our universe is wondrous. Galaxies swirl like eternal dancers, starbirths and supernova deaths light cosmic eons, and black holes swirl matter into darkness. But we found that galaxies rotated too fast, as if more mass hid in halos. We discovered that supernova data implied a cosmic acceleration, so we labeled it dark energy, some invisible fluid pushing space outward. We encountered black hole meltdown singularities where space-time allegedly breaks down. Each time the astrophysics community responded with new dark placeholders or disclaimers, we do not truly know. For the public at large, hearing about dark matter or dark energy might have felt intangible, as though science was telling stories about invisible ghosts. Meanwhile, mainstream physics never quite overcame these intangible solutions. Our standard equations fit data, but at the price of unobserved ingredients, like a puzzle solved with extra pieces that remain intangible in real experiments. Enter the grand Febernachy approach, a single principle that unifies these separate issues into a single cosmic push. Instead of seeing gravity as solely mass-based or curvature-based, it reimagines the entire universe as a dynamic interplay between 1. Subtle magnetic fields, SMFs, high-dimensional magnetisms that intensify with rotation, cosmic conditions, or fractal expansions. 2. Relative vacuum of space, RVS, a vacuum that is not empty but vibrantly responsive, adjusting its pressure or density across scales from star cores to galaxy clusters. 3. Fractal Fibonacci scaling, a self-similar law that ensures this interplay is consistent across all cosmic distances, small stellar orbits, entire galaxies, or the whole universe. In simpler terms, the vacuum itself acts as an agent, quietly exerting an outward push that can replace dark matter for galaxy rotations, replicate dark energy for cosmic expansion, and saturate meltdown attempts in black holes, so no infinite singularities arise. You may have heard that galaxies rotate so fast that we must invoke large dark matter halos to keep them stable. But the grand Febernachy push-based approach says no invisible halos required. Instead, a mild but steady vacuum push intensifies enough at galactic distances to prevent stars from drifting away. Observationally, the flattened velocity curves can be reproduced by letting the fractal expansions in SMF-RVS scale up just enough to produce near-constant star speeds. The actual result is a graceful cosmic dance guided by subtle fields, not hidden lumps of matter. If this is validated further, we release ourselves from searching for elusive dark matter particles that decades of experiments have not pinned down. Another cosmic puzzle. The expanding universe is accelerating as though a strange negative pressure fluid, dark energy, lurks in the vacuum. Because no one can identify it in labs, theories call it quintessence. The grand Febernachy synergy offers a simpler explanation. At large scales, the same fractal vacuum that shapes galaxy rotation gently pushes galaxies outward. Instead of a uniform, mysterious fluid, we get an evolving synergy whose mild push emerges once matter has diluted. This solves acceleration in a single stroke, bypassing the huge mismatch between measured and predicted vacuum energies. The same synergy that explains galaxy rotations also explains the cosmic acceleration, no second unknown. Traditional black holes in Einstein's theory lead to meltdown singularities at their cores, points where density and curvature go infinite, outside the domain of standard physics. Observers might think these meltdown points cannot be physically real, but remain in the math. The grand Febernachy approach says, as matter tries to collapse indefinitely, the SMF-RVS synergy saturates, creating an enormous outward push that prevents infinite compression. So black holes remain black externally, their horizon, but are finite inside. The meltdown is avoided. In effect, black holes remain stable vacuum objects consistent with ring-down wave signals measured by gravitational wave detectors. This is a major conceptual unification. No meltdown singularities, no new disclaimers. Our everyday glimpses of cosmic phenomena also revolve around star births and deaths. The same synergy can unify many star-level riddles, such as supernova. Instead of meltdown shock waves that stall or need neutrino revival, supernova explosions can be spin-driven outflows with a vacuum push assisting ejection. If proven, that solves decades of shock stall complexities, tying supernova outbursts into the fractal expansions at the star's interior. Baryon asymmetry. The fact that matter outnumbers antimatter might be partially due to repeated expansions or bursts in the early universe. The vacuum synergy breaks perfect symmetry just enough to yield a net surplus of matter. So we unify cosmic expansions, star collapses, and matter-antimatter imbalance with one fundamental push-based law. At the heart of this approach is the fractal notion, ensuring that at small scales, like star systems, the vacuum synergy is mild, basically mimicking Newton-Einstein results. Yet as we ascend to galaxies or to cosmic volumes, that synergy transforms into the dark matter or dark energy effect, all the while obeying one self-similar scaling principle. This is reminiscent of how fractals unify structures from micro to macro. So we see fractal expansions bridging everything from black hole cores to the Hubble expansion. Scientists might wonder how such a single principle can be tested or validated. The next wave of cosmic surveys, like the Vera-Rubin Observatory, Euclid mission, more advanced CMB satellites and gravitational wave observatories, may allow us to see subtle differences from standard. For instance, large-scale structure. If no dark matter halos exist, the fractal vacuum push must form cosmic structures with a certain pattern or growth rate. Observations might confirm or reject these predictions. Late ISW effect. The Febernachy synergy might produce small differences in how large cosmic voids or superclusters imprint on the cosmic microwave background. Black hole observations. If meltdown singularities do not form, perhaps ring-down wave signals or horizon imaging might show minute signals consistent with a non-singular interior. As the data rolls in, we can refine the synergy's exponents or baseline couplings, akin to how the standard model was fine-tuned. If the synergy not only fits but surpasses on subtle phenomena, The impetus for a new gravitational era becomes overwhelming. At a first glance, an alternative to dark matter or dark energy might feel intangible to the everyday public. Does it matter how the cosmos expands or how galaxies spin? Yet the importance is profound, philosophical. Freed from the idea that 95% of the cosmic content is dark and invisible, we grasp a simpler, more direct universe. Scientific billions spent on fruitless dark matter searches might pivot to exploring vacuum synergy or fractal expansions, possibly leading to new technology or spin-offs. Inspirational, this unification fosters a sense that the cosmos is not random lumps requiring multiple invisible patches, but a living fractal interplay that is rational, discoverable, and grandly elegant. Moreover, if fractal expansions exist at all cosmic scales, we might discover new energies or field manipulations that open future doors in space travel or advanced observational feats, harnessing or at least acknowledging the universal vacuum push that shapes planetary orbits and galaxy rotations. We see the same synergy bridging star-level outbursts, galaxy-scale dynamics, cosmic-scale expansions, and black hole innards. This might be the final missing link that Newton, Einstein, and subsequent expansions have approached but never pinned down. Instead of layering epicycles, dark matter, dark energy meltdown disclaimers, we have a single impetus. Historically, we overcame separate electromagnetic fluids by Maxwell's unification, overcame inertial versus gravitational frames by Einstein's geometry. Now, we set aside the ephemeral dark sector and meltdown with a fractal vacuum synergy that ties up so many cosmic phenomena elegantly. We stand at a threshold. With data from next-generation telescopes, deeper gravitational wave catalogs, and refined cosmic surveys, we can test whether fractal expansions truly unify the cosmos. If it matches, and initial calculations strongly hint it will, then we might well be living in an epoch akin to discovering Maxwell's equations or forging the Einstein field equations. The impetus is not merely to solve partial puzzles, but to reflect a single cosmic reality that is simpler, more direct, and free from ephemeral placeholders. As we gaze at the star-filled sky tonight, let us recall that each luminous swirl and drift might be shaped not by hidden lumps or intangible fluids, but by an artful synergy of subtle fields and fractal vacuums. The cosmos remains as majestic as ever, but now the patterns behind it glisten more clearly. For centuries, gravity was a story of mass-based attraction. Then, we found we needed extraneous stuff, the dark sector, to patch the story. At last, with the grand Febernachy push-based theory, we see how the entire cosmic tapestry might be woven from one integrated principle. We do not claim final absolute truth here. Any bold new vision demands rigorous testing and iterative refinement. But what an extraordinary leap! Bridging galaxy rotations, cosmic expansion, black hole meltdown, supernova formation, baryon asymmetry, R-process nucleosynthesis, FRBs, magnetism, and more, in a single cosmic synergy. If that synergy continues to pass observational scrutiny, future generations of scientists may look back at our era as the moment we replaced ephemeral ghosts with a luminous fractal push, unifying cosmic phenomena under a simpler, more powerful gravitational code. That is the significance of the grand Febernachy unified theory. It changes our cosmic vantage from dark illusions to fractal synergy, from meltdown nightmares to finite stable objects. Freed from the heavy baggage of missing matter and energy, we can stride forward into a cosmic dawn, forging new knowledge that might one day guide how we harness the vacuum's subtle push in technology or open deeper cosmic frontiers. Let us welcome this revolution with the same zeal that once accepted Newton's laws or Einstein's curvature, embracing a new idea that might at last unify gravity's many guises. Indeed, the cosmic stage has never looked so bright.